CVPR 2026 part one. I want to talk about actually the most interesting ideas that I gathered on this first day. Today is the workshop day. And there's three things I want to talk about. One is Professor Du's presentation. The links are in the show notes. He's a Harvard professor, and he spoke about video reasoning. So I think video reasoning, it's a new concept that I have been not familiar with. So I think it's huge. I want to connect that with Ashock's presentation that he gave, and then also add Ethan He's idea of using, kind of the same concept of reasoning for video generation. I think these, the first and the third are definitely related. Ashock's idea of evaluating models through video generation is probably, I would say, one of the first real-world at-scale applications of this idea. This is not even on podcast. It's June 3rd, 2026. This is Krim Delco. For the year, we're down 80 basis points, marks up 10.4, around falling by 11.2%. So this was the first day of CVPR. And I think we already got some really, really interesting ideas from this conference. And that I want to start with video reasoning. So video reasoning is it's a concept that I have not been familiar with. Certainly, it's been around in the academic community. And the idea is that you have, the same way you have reasoning in large language models or test time compute or understanding, trying to iterate your way through your knowledge base that you already have in order to optimize for a certain task. And instead of doing this with text, you're doing this with video. Now, the underlying backbone and architecture, I'm not 100% sure whether it's the same idea with token prediction and all that. But that's not the most important thing here. I think I want to keep it at high level because that's where we stand here at Orange Capital Partners. We're investors. We're not engineers. So we don't build these systems. We put capital at work. And what we're trying to build here is a system where we generate wealth by solving the real-world AI problem or the robotics problem, if you will. So we wanna enable transportation and work as a service through agents in the real world. So that's the idea. And now, Du's ideas, by the way, he presented a paper that has an all-star authorship on it. So there's Abil is on it, Malik's on it, Tendrak is on it. I mean, all-star East Coast, West Coast collaboration here. And the idea is that you have, you pre-train a model on video, human videos, internet scale videos, and then you train it to reason. So to let's say, they call it dream up, or the point being that you give the model an image, a text prompt, and it generates its own trajectories. It uses model predictive control, so it does a trajectory planning. And I want to throw in here Ethan Hayes' presentation recently, interview that he gave on latent space, which is kind of similar here. What he was talking about was he was talking about using Monte Carlo tree search to generate trajectories for a possible long-form video generation model. So it's a similar idea. Being that you're at a certain point, you have an image, you have a certain situation, you have a certain state, and now you're trajecting forward which states could make sense, and then you have a certain optimization algorithm. In the case of Ethan He's case, he was using RL and optimizing for consistency, coherency, and things like that. So again, the technicalities are not that important here. What's important here is definitely the idea, because what we want to have is we want to have the ability to reason in video space. That's the key, video reasoning. And that brings us to the possibility or the idea, and it was also discussed in other presentations today. So I would even call this a theme at CVPR 2026, that video reasoning could be the next frontier, that we reason through images. And once we have models that can do that, a lot of new things open up. For example, interacting with intelligence through videos and images could be incredibly useful for humans, of course. What we want to focus on here, although, is now on robotics, because that's where we have our money right now. And the point being that you could use these video generation models for robot learning. Now, we have already discussed this in several episodes recently, that we think that real world models, or the difference between world models and video generation actually is that the world models need to be grounded in reality. So they need to have a feedback loop with robot data coming back into the model and then being regenerated and having this feedback loop. But let's talk about Du's presentation here. So Professor Du talks about the idea that you take human videos and then you do kinetic retargeting. So you use several techniques that are available. Again, there's a few papers that are cited in their paper that explain that, how you get from human, slicing an onion and then saute the onion in a pan, how you actually kinetically retarget that to a robot with its limbs and arms and hands and sizes and all the morphology gap, crossing that you have to do there. So that's, technically possible. Certainly there are some issues, there are physics issues, but in principle, this is a path I think worth going. And I think we're going to most likely find out that the bitter lesson will play here. So the more data and the more general training we have, the better these things will get. I think the kinetic retargeting needs definitely some more research here, maybe better ways to do this. But in principle, this is definitely the path forward. And then I think what we believe in, that the world model, so the difference between a video generation model and the world model will be that the world model actually feeds back the real robot data, so the real physical, actual AI data that comes from states and actuator information and state transformation and actuator transformation information back into the model. And then we have a better understanding of the actual physicality of the model, of torque, of forces, and all that stuff. So that's I would say that's really interesting. So video reasoning, I think, as a keyword, chain of frame instead of chain of thought, I think really interesting. Now, Ashock's presentation was about how, it was a general presentation that it wasn't new, actually. There was not a lot of new information in there. But the one thing that he emphasizes is the difficulty of evaluating models. Like when you're at a stage like Tesla, where you have a pretty good supervised FSD, and now you're kind of pushing the frontier of the tail in terms of getting the model better and better. How do you decide what's better? And the way you can do that is through video generation, right? You can generate trajectories and test the model against those trajectories. And I think that's where a real world application comes into play. And I think that's really powerful. So I think, to summarize this first day of CVPR, I think incredibly interesting from our perspective. New ideas, new inspirations, video generation through model predictive control, robotics as a video prediction problem, and video generation also as an evaluation tool for real-world AI, such as FSD. I think those are the big ideas that we took away from CVPR 2026. One thing I want to mention is that I think Ashock did not talk about how FSD actually transfers into Optimus. And I think that would be interesting, maybe as a feedback, if anybody of Tesla is listening, that would be very useful to have some big picture guidelines of how actually FSD translates. Now, he spoke about this a little bit, how the navigation task is the same. But I believe there's more to that. And particularly if we combine the video generation idea with Optimus and then sort of loop it back into what Professor Du was talking about. I think that's kind of the space where we think humanoid robots actually can really translate into real products at scale pretty soon, because there is a scientific trajectory. And I think I want to just step back for a second and give people a little bit of perspective here at Orange Capital Partners. The reason we do these things, we go to conferences and talk about interesting scientific ideas, is precisely for this reason. Like, we want to understand what's out there in the knowledge space, and then what can be translated into tech space and actually products and services, right? That in innovation, you are always tied towards new ideas. and they usually come from academia, but they're not being executed in academia. They're only being executed in companies. But it's certainly not the job of companies to come up with all these new ideas. Sometimes they do, but mainly what they do is they take those ideas. You know, Steve Jobs famously said something along the lines that we just steal from each other. And that's really true in a good way. Like these ideas, they sort of spill over into the real world and really add to humanity through companies. If you will, entrepreneurs and companies, particularly the large tech companies, they're the transformation function that takes scientific ideas and actually transforms them into real products that improve human lives, and that's why we're invested in this space. And I think this is a really beautiful example. That's why I think this is a very successful CVPR so far. Kudos to the conference, kudos also to the people. And this is one of the flagship papers, in my opinion. Just again, look at the authorship. It's an all-star authorship, and I think that's why it's so important. And also kudos to Professor Du. I mean, he's just got his PhD. He's not that old, and he's already working on really interesting ideas. So, and I think this goes back to his PhD, where he actually looked at model predictive control for robot action planning. And that's this is one of the first manifestations. So again, to summarize, video reasoning is a kind of a new phrase that I think we'll hear a lot more in the future, and it's going to tie robotics, model evaluation, scalability, bitter lesson to it's going to tie all these concepts together and enable robotics actually at scale.